Okay, who can tell me what surface area represents? What are we calculating when we're calculating surface area? What are we calculating when we're calculating surface area? Taylor, do you want to give that a go? The area of the surfaces, the area of every surface in a three-dimensional shape. Yeah? Okay. Now with volume, it's again of a three-dimensional shape, but it's the amount of space it occupies. So remember area was more one-dimensional shapes, two-dimensional shapes, sorry. It was just on a flat surface. Volume is how much a three-dimensional shape occupies. Ryan, if you could just pay attention. Yeah. So there are some calculations there that may be useful. Okay, again, as in the test last time, you'll be given these calculations, but you need to understand that volume is measured in cubic centimetres, cubic millimetres, cubic kilometres, those sorts of things. Okay, why is it cubic kilometres, do you think? Why is it cubic kilometres? Why would it be cubic kilometres? Be thinking about your response, because I may ask you. Why would it be cubic rather than squared? Okay, because area is squared, whereas volume is cubic. Jess, did you want to give that a go? Yeah, you're definitely on the right track. Jack?
Because it's like that, the size of that, it's like the size of, the cube centimetre is the size that of a square that you go inside of it. It's weird. I can't explain it.
You're giving it a go, that's the main thing, mate. Does anyone want to help either of those two out a little bit? It's probably best explained by this. Okay, with a three-dimensional shape, you not only have this and this length and this width, all right, that would be area, wouldn't it? Okay, you also have a depth. So there's actually 3 dimensions to this, and so therefore it's centimetres cubed is how we write it. Okay, whereas area is just that 2-dimensional shape, and area is represented by centimetres squared, yeah? All right. Again, you need to know how to work with these guys, and it shouldn't be too difficult. You'll be given them in a test, but you know, if you're going from cubic millimetres to centimetres, you're dividing by 10 to the power of 3, and that is literally what you write in your calculator. Okay? You press the divide button, you press the 1 and the 0 button, and you press the, I don't know what you've got on your calculator, but most have got a y to the, that's meant to be y to the power of 3. Okay, most of you will have that. All right. Some of you might have a button that says x to the power of y. You might have to press that, and then you might have to press the number 3. But over the period of doing this, make sure I can come to you, and we'll be able to go through that. If you're going from centimetres cubed to metres cubed, you'd be dividing by 100, and then that y to the power of 3. Okay? So that's how that operates. The 100 represents the y, and it's cubed, of course. All right? So there's a few things to understand and know there, and if you don't, then it's your responsibility to work that out through 11C1. Question? Yep.
Yeah, there's a question, F, question 2. It's like...
Back up the top a bit.
Oh, no, it's on volume. Yeah, it's like that. Yeah, better, yeah. Yeah, it says 8 times 10 to the power of 10. I can't get the calculator.
Yep, so what this means here, if we just go through this one quickly, what this means, 8 times 10 to the power of 10, it just means, remember 8 times 10 to the power of 1, what does that equal? Do that on your calculator, what does that equal? 8 times 10 to the power of 1, everyone can do that? Have your calculator in front of you? 80, okay? And so, remember in one of your maths homework sheets we had, if we've got 1 there, then it means we've got 1 0 after the number that comes out the front. Do you remember that? Vaguely?
Yes.
So, 8 times 10 to the power of 10. You can stagger it if you want. You can do 8 times 10 to the power of 2. What does that equal, please, Kayla? Have you got your calculator here? Sorry. Jeremy?
160.
800. Okay, so it's not the... It is the number out the front followed by 2 zeros. 8 times 10 to the power of 3. What do you think that would be, Nikita? 8,000. It's the number. And 3 zeros. What do you think 8 times 10 to the power of 10 might be, Cheyenne? 8, good. Yeah, it's a hard one to say. How many zeros? 10, absolutely. I'll probably run out of room on our YouTube channel because I think it runs out there. But 8 with 10 zeros because there's a 10 there, yeah? Is that all right, Ryan?
Yeah, that's good.
Okay, and so that would give you so many cubic centimetres. You'd then have to go to your conversion chart, centimetres cubed to metres cubed. Centimetres cubed to metres cubed, you then divide that by 10 to the power of 100 to the power of 3. Okay? Alright, so volume is the amount of space, and there are some charts in there that you need to know how to use. Alright? Now, there's a few different ways of looking at this, and I'm going to start with... Ryan, can you just try and concentrate on where we're at? I know you're keen to move on with your learning, but if you can just concentrate this way. When we're working out the volume of shapes, and I explained it like this yesterday, imagine this is a block of cheese. Alright, or imagine this is a block of cheese. If I was to slice through this, through that way, I would still have a triangle facing out to me, wouldn't I? I'd still have this triangular shape. Alright? Can you shut your screen, please, Ryan? Thank you. If I was to slice this through here, I would still have a 1, 2, 3, 4, 5, 6-sided shape, which is a hexagonal, facing out to me. Alright? So what I'd like you, when they're uniform cross-section, what it means is every time we cut it through somewhere, we get the same, uniform being the same, yeah? We get the same face facing out. Does that make sense to people? Have you done some of this before? Hands up if you have. Yep, okay, so a majority haven't, it would appear. So what you do is you work out the area of the cross-section and just times it by the length. So for this example, alright, the cross-section is this shape here, and we know that the area formula, again we're using an area formula, which is why it's really important we know our area formulas. What's our area formulas, please, Trent?
Half base times height.
Good. Half base times height.
Yeah.
Alright, so provided we knew the base and provided we knew the height, we could work out the area of that and then times it by the length, which is that distance there. Okay? So every time, just think of it as a block of cheese or a block of butter or whatever. If you were to slice a knife through there, you would end up with a uniform shape that looks like that. And if you could calculate the area of the face and then multiply it by the length, the area of the cross-section, and multiply it by the length, you're going to get the volume or the amount of space that that unit takes up. Alright? So, when we apply that to some questions, there's a question there. Again, imagine that's a block of cheese. There's your face. Okay, that's your uniform face. It's 7.5 by 4.5. Okay? They're doing it length times width times height. That's alright. We could still do 7.5 times 4.5 and multiply it by 6. Let's have a look at that. Based on what we just learnt, the area of the cross-section. Let's try that. Okay? So how would this first go for the volume of this? It would be area of cross-section times by the length. So how do we work out the area of the cross section first, please? Bear in mind, I may ask you, so be ready to area of cross section. I'm suggesting that we could cut it through there, and we'd continue to have this face facing us if we were to slice it and slice it and slice it. So Harry, what shape have we got?
Hexagon.
Yeah, not quite. If we were to slice that through there. Sorry?
Rectangle.
A rectangle, good. And what's the area of a rectangle shape? Length times width. And then we have to, so that's that bit. And then we have to times it by the length, or times it by the depth. Alright? What's the length times width of this one here, please, Harry?
7.5 times 6.
7.5 times 6, is that 6?
Oh,
4.5. 4.5? And we'd multiply it by 6, yep. Okay, so for this, because it's different, let's call it D, we multiply it by 6. Kayla, what's 7.5 times 4.5, please? 33.75. Times that by 6. 202.5. And so what you'll find, again, like I've said a lot of the year, there is more than one way of doing mathematical problems, and you still get the same answer. Okay? So the area of the cross section works for this. Okay? Now, if we were to look at this one, do we know the formula for the area of a hexagon? No, we don't. But beautifully, they give you the area of that. Okay? They actually give you that at calculation. That being 30 centimetres squared, the area of the cross section 30 centimetres squared, and we multiply it by the height, being 11, which gives you that answer. So 202.5 cubic centimetres are in there. Have you ever seen little sugar cubes? Ever had, hands up if you've had a little sugar cube in your hand, or you've at least seen one? Almost all of you. What it's saying is if that cube of sugar was a cubic centimetre, there'd be 202 of them and a half into that shape if the measurements were that. Okay? In this hexagonal shape, there's 330 of those cubes that would fit in if it was 11 centimetres with an area of the cross section of being 30 centimetres. Okay? Because it's the amount of space that it takes up. Alright, any questions with that so far? Or can I explain it better? So the reason why this is important, explain to me please, why does this relate to your M&M's project so much?
You've got to find out how much space it has.
You need to find out how much space what has. The M&M packet. What else?
And the volume of the packet.
The volume of the M&M itself. So you got the volume of your M&M itself. So you're going to get your volume of one M&M, yeah? And you're going to use the volume of an ellipsoid for that. Okay? The volume of the ellipsoid will give you that. And then you're going to create a container for it, aren't you? A three-dimensional container. Now that three-dimensional container, say it's this, okay? Say one of your M&Ms takes up 2 cubic centimetres, okay? 2 cubic centimetres. How much space would 30 of them take up? Cheyenne? How much space would 30 of them take up? 60 cubic centimetres. When you do this shape, you want to do the calculations, and I know you're there, Luke, at the moment. You want to do the calculations on that and say, does it equal at least 60 cubic centimetres? And if it does, it's big enough to hold all of your M&Ms, isn't it? Sean, stay with me, mate.
So they're not squares.
Sorry?